Yes, welcome to DC Economics. So I'm going to take you on how to find the eigenvalues of a matrix. The eigenvalue is explained to be a scalar associated with a linear set of equations which when multiplied by a non-zero vector is equal to the vector obtained by transformation operating on the vector. It is given by taking out AI which is equal to lambda v, whereby lambda is considered to be the eigenvalues of a matrix. So AI is equal to lambda v, as I told you, where lambda is considered to be the eigenvalues of a matrix. So this kind of equation can be represented. The above equation can be represented as taking out a minus lambda I equals to 0. So where I is the identity of a given matrix. So where I is the identity of a matrix of the same order as A. So we may take out the identity matrix and transform it into determinant. The equation can be presented in the determinant way. That will be equals to determinant of, we put out the absolute value that shows the determinant's value that is given by A minus lambda I, which is equal to 0. So this above equation of determinants show up the relationship where now it is possible to calculate the eigenvalues of the matrix. That the eigenvalues of a matrix is represented by lambda. Let's look on the steps to find the eigenvalues of a matrix. The first step, make sure the given matrix A is a square matrix. Also determine the identity matrix of the same order. Second, estimate the matrix A minus lambda I, where lambda is a scalar quantity. Step 3, find the determinants. Step 3, find the determinant of a matrix A, whereby is given by, we take out lambda I and we equate it is equal to 0. The first step that from the equation that's obtained, now we need to calculate all the possible value of lambda, which are the required eigenvalues of a matrix A. Now after understanding the steps, now let's look at an example. Find the eigenvalues of the following matrix that we have A, which is equal to 2, 4, 1, and 5. This is 2 by 2 matrix. Solution. We take out lambda minus, we take out A minus lambda I, whereby we fixed out to find the determinants by taking 2 minus lambda on the right diagonal and 5 minus lambda. Then we times 4 times 1 on the right diagonal. So this will give you 2 minus lambda, then 5 minus lambda. Minus, when we take out 1 times 4, the answer will be equals to 4. So we equate it is equal to 0. So when we times the equation, this will give you 10 minus 5 lambda minus 2 lambda plus lambda square minus 4, which is equal to 0. So when we times the equation, this will give you lambda square minus 7 lambda plus 6, which is equal to 0. So we may use a calculator to solve the first and the second lambda. That will give you 6, the first lambda, and the second lambda, which is equal to 1. So when you take out 1 lambda minus 6 and equate is equal to 0, you obtain 6 that is positive. And when you take out the equation lambda minus 1 and equate is equal to 0, you obtain 1. So the eigenvalues will be 6 and 1. Now after looking, so let's look at another example. Example number 2. Find the eigenvalues of the matrix A, which is given by 2, negative 1, 0, and 1. Solution. We take out the matrix A, which is equal to 2, negative 1, 0, and 1. We find the determinants on this kind of matrix by equating the right diagonals with A minus lambda I. That will give you, we take out 2, we times lambda on the right diagonal. We take out 1 minus lambda on the right diagonal. Then we take negative 1 times 0. So we find the determinant on this kind of of equation that will give you 2 minus lambda, then 1 minus lambda minus 0. When you take out 0 minus, you get 1 minus negative 1 will be equals to 0. So when you create the equation, we will obtain the two equations, 2 minus lambda and 1 minus lambda, which is equal to 0. So when you solve it by using normal way, that will give you negative lambda, which is 0 minus 1. We shift out 1 to the left hand side, we obtain lambda is equal to positive 1. The same applies when we take 2 minus lambda is equal to 0, and we shift it 2 on the right hand side, we divide by negative, the answer will be equal to 2. So the eigenvalues of the matrix is equal to 1 and positive 2. So these are the eigenvalues as we can obtain. Let's look the said example on how we can find the eigenvalues of the matrix. Now suppose you have 3 by 3 matrix. How can you solve the eigenvalues of the matrix? For example, calculate the eigenvalues equations and equivalence value for the following matrix. Suppose we have A, which is equal to 3 by 3 matrix. We have 1, 0 and 0 on the first row. We have 0, negative 1 and 2, and we have 2, 0 and 0. So from this kind of matrix A, that is 1, 0, 2, 0, negative 1 and 0, 0, 2, 0. Now we need to find out, we need to equate out on the right and high diagonal, we minus lambda from the 1, and at the center we take off negative 1 minus lambda, and to the 0 we minus lambda. So we find the determinant on this kind of matrix. So when you find the determinants, that will give you determinants of A minus lambda I, which we equate is equal to 0. So we take 1 minus lambda, we times negative 1 minus lambda, then we times negative lambda, then times minus 0. So this will give you, when we take out negative 0 plus 0, which will give you 0 exactly. So what will come to obtain here, this will be equals to lambda brackets 1 minus lambda, then bracket times, we take out 1 plus 1 plus lambda, which is equal to 0. So from this kind of equation, we are capable of solving now the eigenvalues of the matrix. So we take out the first equation, 1 plus lambda, which is equal to 0. We solve for the lambda, we take out 1 to the left hand side, it will be added, so it will give you lambda is equal to negative 1, and we take the second equation, that is 1 minus lambda, that will give you exactly 0. So the eigenvalues of the matrix will be equals to, the eigenvalues of the matrix will be equal to 0 and negative 1. Yes, for more understanding, let's look on the last example. For example, find the eigenvalues for the following matrix. Suppose you have the matrix A, that is 6, 4, 3, and 5. Solution. So for matrix A, that is A, which is equal to negative 6, 4, 3, and 5. So when you take out A minus lambda I, and we equate out, we minus lambda on the left diagonals, that is 6 minus lambda. On the right diagonal, we take 5 minus lambda, we take out 4 times 3. So the eigenvalues, when we find the determinant in the equation is equal to 0, it will give you negative 6 minus lambda times 5 minus lambda, then we times 4 times 3, and we equate it is equal to 0. So this will give you exactly negative 6 minus lambda, then times 5 minus lambda, then minus, then we take out 3 times 4, which is equal to 0. So this will give you at the end it will give you, we take out 6 times 5, negative 6 times 5, that is 30, minus, we take out 5 times 6, then we take out 5y, it will be negative 5y plus 6y plus y lambda square, then minus 12, which is equal to 0. So when you get the equation, it will give you exactly the required eigenvalues, that is 6 and 7. So that marks the end. Welcome to DC Economics. Bye bye.